Hello everyone, today in the video, graphing a polar curve. Given a polar equation, r equals 1 plus cosine theta, which is a cardioid, we can graph it by first plotting the equation in the xy plane with r being y and theta being x. Why do we want to do this? Because we can come up with a graph more easily without having to make a table with a long list of values and tedious plotting. So, let's get started. We now graph r equals 1 plus cosine theta in the xy plane. Start with a graph of the basic cosine function. This is one period of the graph. The 1 in the equation shifts the basic cosine graph 1 unit up vertically. So, that's our polar equation plotted in the rectangular plane. Now, how does this graph help us graph the cardioid more easily? Here's the idea. The vertical distance between each point on the graph and the x-axis is how far each polar point is from the origin. Using this idea, we can start graphing. Starting with theta equals 0, we see that the vertical distance is 2. So r is 2 and theta is 0. Plot the point with a distance of 2 units from the origin when theta is 0. Other points that are extremely easy to plot are pi over 2, pi, 3 pi over 2, and 2 pi. We see that at pi over 2, r is 1. At pi, r is 0. At 3 pi over 2, we get r to be 1. Coming back to 2 pi, we get 2, which is our starting point. Now, only having these 4 key points may not be enough to graph the polar curve. So we start looking at some other easy points. For example, from the graph, we can see that we have a y value of 1.5 at pi over 3. So we have a point 1.5 pi over 3. And by symmetry, we get another point here. In fact, we may not always get nice values like this. So we usually try to approximate. Here's how we can do that. Starting from the initial point, we see that the y value starts at 2 and starts decreasing. So, on our polar plane, we start drawing the curve by going in the counterclockwise direction, and we need to make the distance from the origin smaller and smaller. See that all the distances from the origin will be decreasing from 2 to 1 as we get to a key point 1, pi over 2. Getting past pi over 2, the y values are getting smaller from 1 and decrease to 0, then we arrive at the next key point, 0, pi. Using the same idea in symmetry, we can complete the other half of the graph more easily than the first half. So, we have the final graph. So, that's the idea for graphing polar curves. We'll do another example next time. Stay tuned. Please give me a like and subscribe to my channel to show your support. Thank you. I will see you next time.